All right, well, good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 28 is on the screen, and it reads number 1, solve. It's a rational equation that reads x squared minus 29 over x squared minus 10x plus 21 equals 6 over x minus 7 plus 5 over x minus 3. For number 2, we have write the compound inequality shown by the graph, and it's a number line. And we have one graph starting at -1 pointing to the left, and the other graph starting at +2 pointing to the right. From there, we go to number 3, which says evaluate the function and graph using the domain -2, -1, 0, 1, and 2. And they give us the function f of x equals -2x plus 1. I'll give you some time for that. Ready, go. All right, so number 1, once again, oh, snap. Sorry. Okay, there it is. Okay, let me make some room here. So number 1, they're asking us to solve, and what is the first thing we need to do? We'll look at it. It's a rational equation. We need an LCD. That means we need the denominators. We have 1, 2, 3 denominators. And then after you find the common denominator for 2, and then you factor the other one, 21 and -11, we find that our LCD is x minus 7 and x minus 3. Once we have that, multiply the entire equation times those two. And once again, you multiply times x minus 7, x minus 3, yada, yada, yada. Afterwards, after you simplify, you're going to end up with, let's see, x squared minus 11x plus 24 equal to 0. Factor that out. You end up with x minus 3, x minus 8. All that equal to 0. When you solve, you get x equals 3, x equals 8. Hands if you got that. Okay, good. However, the excluded values, if we get the denominators, we got x minus 7 equal to 0, x minus 3 equal to 0. That means if we solve, our excluded values are 3 and 7. So what does that mean, Mr. Q? Well, if the excluded value is 3 and one of the solutions is 3, that means 3 cannot be a solution because it's an extraneous. So the only solution is 8. Hands if you got that. Let's go. Number 2, it says write the compound inequality shown in the graph. So notice now the two graphs do not intersect. So there's only 2 types of compounds. There's and when they intersect, or, which is this one. So this is our or compound inequality. So let me write the inequality for this section. So this is going to be represented by x. My dividing point starts at 1. There it is. And -1, sorry, -1. And let's see. According to all these numbers, this is -1, this is -2, this is -3, -4, -5, and it keeps going all the way to -infinity. All these numbers are what compared to -1? Yeah, they are less than. However, is this point right here, the green one, is it a solid point? Yes, it's a solid point, Mr. Q, right there. Yeah, so that means we put an equal sign. Okay, let me do the inequality for the red one. Once again, all these are represented by x, and my dividing point starts at 1, 2. It starts at 2. Okay, so question, here's 2, my dividing point, and all these numbers right here are 3, 4, 5, 6, ... to positive infinity. It keeps going. All these numbers are what compared to 2? That means x is what compared to 2? Yeah, it's greater than, since it's a solid point, is equal to. And what do we write in between? This is an or. That's my inequality. However, I like it written in what? Solution set. Is that correct? Yes, Mr. Q. Solution set of x such that those inequalities, and you close your bracket. Okay. And the last one, number 3, it says evaluate the function. We already did one the other day, but I'm just going to do one value, the value of -2. So it's f of -2 equals -2 times -2 plus 1. F of -2 equals 4 plus 1, and f of -2 equals 5. So that's how you evaluate. So that's our domain. So that means when f is -2, the range is 5. Then the next one would be -1, that's 3. The next one is 1. The next one is -1. And the next one is -3. Hands if you got that. Okay, good. And then the graph that goes with it. But you guys can graph. Okay. I want to move on because we need to get on with this session. This session is going to be very robust, and make sure you stay focused. And any little spare time that you have, start making coordinate planes. I need them from -10 to 10 on the domain and range, coordinate planes. And you need at least 2 highlighters for today in your colored pens, okay? All right, so our agenda for today, warm-up number 28. Today is going to be our intro to functions. And our home play is pages 12 through 14, numbers 1 through 11 only. You're like, what, Mr. Q? 12 through 14? Oh, yes, 12, 13, and 14. Yes, those pages, numbers 1 through 11 only. All right. Warm up number 28, intro to functions, and so on and so forth. Okay, asynchronous code. BWZEN, BWZEN. For your Nearpod, asynchronous code is BWZEN. And once again, in case you get kicked out or you're watching the video lesson, use that code and it should give you all the notes for the session for today. Okay. And your asynchronous means that you need to take pictures of your notes and submit every time that you have a toolbar on the slide that you arrive at that presentation. All right, get your home plate out. Well, actually, you should have already have it electronic. Turn it in on Canvas. It was 10 problems for slope and slope-intercept form. Turn those in, please. I'll give you some time now. All right, once again, your home plate for tonight is pages 12 through 14, problems numbers 1 through 11 only. All right, let's get this show on the road. Our objective for today, I can identify functions. So yeah, we did a lot of work already in the past for the past, 8-9 weeks. And all that's gonna come together today. Hopefully makes a lot of sense. And you're gonna be like, oh, I see what you did there, Mr. Q, getting us to learn all these other things in between, yeah. However, before we get a fair model started for functions, I want us to go over some vocabulary, okay? Look up, please. So this vocabulary, you don't have to copy it right now. It's stuff that we've been talking about already. You can do that when you do your asynchronous code, and then in case it has a toolbar, you can submit. But here it goes. I just want to clarify. Ordered pairs are also known as coordinates. Have we been using those? Yes. The first value inside of the parentheses is an x value, and the second one is a y value. Example, if I was to give you the ordered pair or coordinate 2, 3, the x value is 2, and the y value is 3. Have we been doing these or using these? Yes, Mr. Hugh, on the warm-up, we graph with these, yes. However, if I was to get a bunch of ordered pairs together, that is known as a relation. Look up to the screen. A relation is a collection of ordered pairs. So if I gave you this collection of ordered pairs, 2, 3, 0, 0, 103, -5, 7, and -2, -3. All these together is known as a relation. All it is putting together a lot of points, a lot of ordered pairs, a lot of coordinates all together, and it's known as a relation. However, now that we have a relation, I can actually ask you for some information from that relation. Look at the relation. If I was to ask you for the domain, what am I talking about when I say domain? Well, we've been practicing this on the warm-up, but let's see if it rings a bell. The domain is all x values of a relation or function. So if you look at this relation, look at it. and I asked you for the domain, can you picture them? Yeah, let me make it pop. Here it goes. 2, 0, 100, -5, and -2. Yes, that's my domain because it's all the x values. But if I ask you to write it, you would write all the x values. However, you write them from least to greatest. Let me repeat that again. You write them how? From least to greatest. Which one would go first? Let's see. Let me look at the domain here. The first one would be -5, and then -2, and then 0, and then 2, and lastly 100. So it would look something like this: -5, -2, 0, 2, and 100. Is everybody following so far? Yes? So if the domain is all x values, what did I say was the other term that we worked on? The range. Yeah, the range is all y values of the function or the relation. So look at the original relation I gave you. Can you picture the range? Yes, Mr. Q. All right, let me make it pop. There it is. So what is the range? 3, 0, 3, 7, -3. But if I asked you to write it, what would you write? Starting with what? From least to greatest. What is the least? -3, and then 0, and then 3, and then 7. You're like, what? The 3 is next, Mr. Q. Yeah, we only write it once. We don't repeat numbers. I did that on purpose. Okay, does that make sense? Yes, Mr. Q. All right, so any questions with the vocabulary so far? We know what ordered pairs are. We know what a relationship or a relation is. It's a collection of all those ordered pairs, and we know domain and range. All right, so with that said, let's move on to our Freire model. Functions. Oh, my bad. Before we do. Different ways of representing relations and functions. Look up. The first one that we've practiced already on the warm-ups is a table. Have I given you practice with the table? Yes, Mr. Q. How about have I given you practice with a graph? Yes, Mr. Q. The only one I haven't given you a lot of practice this year, in the past I have, when you were in middle school, hopefully it rings a bell, is this one, mapping diagram, a mapping diagram, okay? So those are the 3 different ways of representing a relation or a function. So that you know that I didn't give you the relation, I'm gonna ask you guys to give me ordered pairs. So let's see, give me an ordered pair, please. Octavio, ordered pair.
2 and 4.
2, 4, okay. Another ordered pair, Angela Miramontes. Angela, you there? Okay, help her out, Mia.
-6, -3.
-6, -3. Another ordered pair, Alberto, with your loud mic.
8 and what, 10?
Okay, thank you. All right, so are those different ordered pairs? Yes. What do we call all these together? Once again, they're called a relation. Okay, so let's use the table to set our ordered pairs in there. So we got 2, 4. We got -6, 3. -6, -3, and 8, 10. All right, now let's use the graph to represent that relation. We got 2, 4, -6, -3, and 8, 10. Okay. So do we know how to use the table to represent that relation? Yes. How about a graph? Yes. How about a mapping diagram? Some of you are like, I think I remember, Mr. Q. Well, let me show you. Look up, please. Here's my x values that go here on the x, but look how I'm going to write it. Look up. -6, 2, 8. Now let me write my y values. Here are my y values here. Let me write them here now. -3, 4, and 10. So what do you notice? That for the mapping diagram starts from least to greatest. Same thing with the y, least to greatest. Mr. Q, why is it called mapping? Well, because you need to map the relation of one number to the next. So 2 corresponds to what number? To 4. So you need to show it. 2 corresponds to 4. What else? -6 corresponds to -3. -6 to -3. And the last one, 8 to 10, 8 to 10. I don't see the difference, Mr. Q. The difference is that there's going to be times when these are not in order and arrows are going to change. And I'll show you that once we get to the next example. Okay. All right. Once again, copy this. I'll give you 30 seconds. Go. All right. So fairly simple, yeah? Yes, Mr. Q. I remember these. All right. So let's move on. What are functions? Here we go on your Frayer model. Functions. Functions, a relation that assigns exactly one output value for each input value. A function. A function is a relation that assigns exactly one output value for each input value. Examples. First example, they give us a relation inside brackets, and they give us ordered pairs. So first ordered pair is -2, 3, then -1, 4, then 0, 5, then 1, 6, then -2, 3. Another example is y equals 2x plus 1. In function notation, it should read f of x equals 2x plus 1. Another example is y equals x squared minus 1. In function notation is f of x equals x squared plus 1. Minus 1. Another example is y equals 2 to the x power plus 1. In function notation should be f of x equals 2 to the exponent of x plus 1. Copy that, and then I'll go over it with the definition. All right, here we go. So, according to the definition, a function is a relation that assigns exactly one output value for each input value. So what would be the contrary? Well, that it assigns not exactly one output value for each input value. So how can we know, Mr. Q? Well, let me show you. Look up to the screen. So here they give us a relation. It's like 1, 2, 3, 4, 5 ordered pairs. To check if it's a function, pay attention to this. See if any of the x values repeat. Let me repeat that again. If it's a function, first check to see if any of the x values repeat. They're like, let me see, -2, -1, 0, 1, -2. Yes, Mr. Q, -2 repeats. Whenever you have an x value that repeats, the first thing that you need to do is draw a mapping diagram. Okay, so here's my mapping diagram. Map. Okay. And then let's start with the first one. The first one we have -2 and 3. Okay, -2 and 3. Okay. Let me go to the next one that repeated, -2. What is the output? It's the same one, Mr. Q. Okay, so if we were to sketch the relation, let's see, for the input of 2, the output is 3. So there's only one output. So that's how we can check if it's a function. If the x value repeats, the output has to be the exact same output for both. Does that make sense? If the -2 repeated, then the output should have been 3 also. So this one was -2, 3. This one, -2, 3. It is a function. Okay. What else, Mr. Q? Well, these, I'm letting you know that they are functions because I gave you a function notation, but I'm going to give you the graph and the name of these. This is a linear function. Linear function, the graph looks like that. This one, since it has a square, this is known as a quadratic function, and it looks like this. It's a parabola, quadratic function. And the last one, this is an exponential function, and the graph looks like this. Exponential function. Those are the functions that we're going to be working with. Eventually, we're going to get to the exponential one. The one we're going to be working with the most so far right now is the linear, quadratic, and the cubic. So make sure you get used to those, okay? So copy that, and then I'm going to give you non-examples. All right, so let me give you non-examples. Here we go. Here's a non-example. They gave us a relation, because it's a lot of ordered pairs, and on the relation, in brackets, they give us the ordered pairs -2, 3, -1, 4, 0, 5, 1, 6, -2, 7. Copy that. And also, this graph right here shows us a parallelogram inside of the coordinate plane. You don't have to be exact with your numbers on the x or the y axis, as long as you just show this parallelogram on there, and then I'll elaborate in regards to why that is not a function. Copy that, please. All right, so look up really quick. So I gave you some non-examples, and what did I say whenever you had a relation like this to check to see if it was a function? What do we do first? Check to see if there's any x values that repeat. Are there any x values that repeat? Yes, -2 and -2. So as soon as you see x values repeat, you create a mapping diagram. Here's my mapping diagram. So my first order pair in the mapping diagram are -2 and 3. So -2, 3. Okay. Let me go to the next one that repeated, -2. I don't rewrite -2 because I already have it here. It's already there. But the 7 I do write. So the 7 goes right there. So now let me show the relation for each one. -2 goes to 3. -2 goes to 3. And this one, -2 goes to 7. So now by looking at it, how many outputs does -2 have? 2, 3, and 7. That's why this is not a function, because the definition says there's only exactly one output for each input. How many outputs does this one have for -2? 2. That's why that's not a function. Next, look up to the screen. Look at this graph here. I'm going to go to the value of x1. x1 is right here. Look up right there. Now, according to this graph, if the graph is on the coordinate plane, there should be a point when x is 1 on that graph. So when x is 1, is there a point on the graph? Yes, right here, Mr. Q. 1, 1. You're like, there's another one, Mr. Q, down here. Yes, down here at 1, -2. Well, guess what? For this one, that one's not a function, because for x1, how many y values does it have? 2 of them. That's why it has 2 points. And in the past, those of you that were with me, I said we can do a vertical line test by drawing a line straight down. If the line touches at least in 2 points on that graph, it's not a function. Okay? All right, so with that said, hashtags. What makes a function a function? Hashtag what? Hashtag what? Danny, hashtag what? What makes a function a function?
Hashtag only one output for one input.
Only one output per input. Thank you. What else?
Hashtag X pairs.
Oh, snap. What? You're loud.
What do you mean?
Oh my goodness. Whisper. What was it? So what? What'd you say, Alberto?
X pairs. Is this bad from here?
Not bad. X what?
X pairs.
X pairs? Okay, X pairs. Oh, I see. That if you have some X's that they need to be exact outputs, okay. What else? One more. Hayden, hashtag what?
Relation.
Relation. That is correct. A function is a relation. Yep. All right. So now that we have that, let's move on. I'm going to give you some more vocabulary, and this one in regards to a different notation that we're going to use. So far, we've used set notation, haven't we? Throughout the school year, in the warm-ups, I gave you write it in set notation, solution set of X. Remember? That's set notation. We're going to be using that today. However, a new notation that we're going to be talking about today is known as interval notation, okay? But what is an interval first? An interval is part of a line without any breaks. So if I was to give you a function and I asked you to look at that function and I asked you to look at an interval, that means you're only going to look at a certain portion of that line and make sure there's no breaks in between that line. So here we go. Types of intervals. The first one known as a finite interval. The finite interval has two endpoints. Finite meaning that it stops at the ends or that the ends are included. Now, what is the notation that we're going to use for that, Mr. Q? Well, the notation to include the endpoints are brackets. Look up. This bracket and this bracket mean that the ends are included. This bracket and this bracket tell us that the ends are included. This is known as what? Finite, because they are included. The other one is known as infinite. That means that it's unbounded or that one or both ends are not included. Let me repeat that again, that are not included. The first one is included. This one is not. So how do we indicate that it's not, Mr. Q? With parentheses. If the endpoints are not included or are unbounded, you use a parentheses to indicate that, because we're going to be writing short notation using this, okay? So to get us started, I'm going to give you a table for you to make a table, and then you're going to copy the graph, and then I'm going to walk you through the first one, and then we're going to do the next three together, okay? Here we go. Example Q. Copy this table, please. The first column, label it inequality. The next column, label it set notation. The next column, interval notation. The next column, description of interval. And the last column, type of interval. And on the first column, I want you to add this graph. We have a number line, and there's a graph pointing to the right with an arrow, and it's in red. And in the beginning point, it's an open point between -4 and -2. Copy that really quick. All right. All right, so here we go. So I'm going to start with this one. And this is just like a little bit of practice of what we did at the beginning of the school year. Remember when we got to inequalities? Here it goes. I'm going to do this one in black. So it says inequality. So here we have the dividing point starting at what number is that? -3. And it's shaded all the way to the right in red, and it keeps going because it has an arrow. So that means if all this shaded region is a variable, I would label it X, but it starts at what? -3. So my inequality would read X is greater than -3. Does that make sense? Yes, Mr. Q, because all this is X, this is -3. What are these compared to -3? X is greater. Now, how come it doesn't have an equal sign? Because it's not included. This is an open point. All right, how do we write it in set notation? Well, solution set of X such that X greater than -3. There it is. Okay. Now, here goes where some of you get confused. Notice that the arrow keeps going. That means that it's going to continue going to positive infinity. Question, do we ever catch up to infinity? No, because it keeps going. So, question, so is positive infinity included? No, because we never catch up to it. It's unbounded. How about, is -3 included? No, Mr. Q, -3 is not included because it's an open point right there. So let me show you how to write it in interval notation. Interval notation, we start at -3, and then we write positive infinity inside parentheses. -3, comma, positive infinity with parentheses. What does a parentheses indicate? That -3 is not included and positive infinity is not included. What does that mean in words, Mr. Q? Well, look at it. It means that all these, including all the numbers as it continues going, all real numbers greater than -3. All real numbers greater than -3. Now, what kind of interval is this? There were two types. There were infinite or finite. Since this one has an arrow going towards infinity, that means this is an infinite interval, infinite. All right, so as you finish off that one, copy these next 3 graphs, please. Make some space so that we can fill in the rest. Copy those really quick and give you some time. Hurry up, please. Go. All right, so let's see where we're at. We have the next graph down is a graph pointing to the left with an arrow that keeps going. And the dividing point starts at 4, +4. Okay, the following graph, the next one after that, is a graph on a number line that's in between dividing points -2 and 5. And -2 and 5 are open points, and it's shaded in between those two. And the last graph is another graph that starts with a dividing points -5, and it ends at -2. -5 is included. It's a solid point. It ends at -1. And -1 is an open point. -5 is closed. -1 is open, and it's shaded in between. All right, let's go with the second graph. The second graph, I'm going to do that in blue. So we have all this representing which variable? X. And what's my dividing point? 4. So question, what are all these numbers right here? 2, 1, 0, -1, 2, and all these as it continues going towards negative infinity. What are all those compared to 4? They are less than. That is correct. However, since this point is a solid point or it's a close point, we need to put what? Or equal to. There it is. All right. What does that look on set notation? Well, solution set of X such that X less than or equal to 4. You're like, Mr. Q, this is easy. Oh, yeah. Next, interval notation. Question. The arrow is pointing towards negative infinity. That means we're going to use negative infinity. What other number are we going to use? +4, because that's our dividing point. So I write negative infinity, comma, 4. However, do we ever catch up to negative infinity? No. So what do I use for notation? Oh, parentheses. Oh, yeah. Parentheses means that we never include it. Okay. However, is 4 included? Yes. So we use the bracket to show that it's included in our notation. You're like, oh, I think I get it, Mr. Q. Yeah, there it is. And what does that mean? It means all real numbers less than or equal to 4. Now, notice this one. It also keeps going to the other side of infinity. That's why this is an infinite interval. Infinite. All right, I'm going to switch to red now. Let's go to the next graph. Can we write an inequality for this? Oh yeah, Mr. Hugh gave us practice of this. What kind of inequality is this? This is a compound inequality. Yes, because of the shading in between. It's an and, okay. So if I write my inequality, it's in between what dividing points? -2 and 5. We got x. Arrows to the left. So it reads -2 less than x less than 5. Do I put equal signs underneath the inequality symbols? No, because these points are what? Open. All right. So what would be my set notation? If I was to ask Jaziel for set notation, she would say, oh, Mr. Q, it's solution set of x such that -2 less than x less than 5. Yes, Jaziel, that's totally correct. And then if I was to ask Blanca for the interval notation, she would say, oh, it's in between -2, 5. However, is -2 included? It's open, no. Is 5 included? No. So how do we indicate that here? Parentheses, parentheses. So what does that mean in words? The description. All real numbers between -2 and 5, comma, what else? Not including -2 and 5. Or in other words, not including the dividing points. Look at the graph. Are there any arrows on the graph for that inequality that we wrote? No, since they don't go to infinity, then this one is a finite interval. Finite. All right. And the last one. Let's see. Mia, help us with the last one. What are my dividing points for the last one?
-5 is less than or equal to x, and which is less than -1.
That is correct. -5 less than or equal to x less than -1. Notice that she said less than -1 because the last one is an open point. So my solution set would be solution set of x such that -5 less than or equal to x less than -1. All right, so interval notation. Help me with the interval notation, please. Esmeralda. What would you write?
-1, -5.
Close. We start with the smallest one or the one farthest to the left. So it's -5, -1. Do we include -5?
Yes.
Yes, so we use a bracket. Do we include -1?
No.
So we use what?
Parentheses.
Parentheses, yes. And on this one, we would write all real numbers between -5 and -1, comma, not including -1. What kind of interval is this? Yes, finite. Not Fortnite, finite. Really, Fortnite. Does anybody still play that? Yeah? No? Okay. All right. So that's going to be probably about half of the home plate tonight. Just writing the different notation. But where I want to get to is the next one. Here we go. We only have a couple minutes left. Here we go. Look up, please. Write your utensils down. Look up to the screen. So right now I'm going to have your brain focused on my coordinate plane. I'm going to take my highlighter and I'm going to highlight a section of my coordinate plane. Look up. I highlighted part of my coordinate plane. If I was to ask you for the domain of that highlighter section, your focus is going to be on the x-axis, isn't it? Yes, Mr. Q. And if we read it from left to right, my domain starts where? At +2, and it ends where? At +8. Let's see, from +2 to +8 will be my domain. Okay, I see what you're doing, Mr. Q. Let me give you another section. Look up. If I ask you for the domain of that shaded region of my coordinate plane, you would say what? Show me with your fingers from where to where. I see some -3, okay. 2, 3. Let's see. From -3, here's -3, all the way to 3, yes. All right, on your coordinate plane, shade this section, please, with one color. Hurry up, hurry up, hurry up. And if I asked you for the domain for that, what would the domain start and end? Let's see, I haven't picked, have I picked Josiel already? No, I haven't. Josiel, where does it start and where does it end, that domain?
-9 and 4.
Let's go. You remind me of me in kindergarten. Let's go. All right. So yeah, so that's how we, guys, so that's how I ask you to read the domain from left to right on the x-axis, yes? With that same idea, I'm going to be asking you for the range. Look up. Look at this one. I highlight it, but now sideways. But to give me the range, we start from the bottom to the top on the y-axis. Look at it. Way at the bottom, where does that shading start? It starts at +1 of y, and it ends where? At 9. Look up. It starts at 1, and it ends at 9. Right now, I'm looking at the y-axis, yes? Okay, shade this on that same coordinate that you had earlier, that coordinate plane, with a different color. So look at it. If I asked you for the range for this one, Josiel, has someone?
Addison.
Addie, what would be our range? Where does it start and where does it end? Yeah, we couldn't hear you. Whoa, okay.
1, -3.
Okay, so we always start from the bottom to the top. So she said -3 and it ends in 1. Does everybody see that? And that's how we read the range on the y. Now, why do you need that, Mr. Q? Because on the next coordinate plane, I want you to plot these 2 points, please. Plot -5 and -2 and 7, +4. Plot those 2 points and draw me a line segment between. And I'm going to say that this is a function. -5, -2, 7, 4. Okay, look up. If I was to ask you for the domain, that means I only want the x values. Is that correct? So I would take my highlighter, look up. So for this function that we just drew, the domain is from where to where? From -5 to what? To 7.
To 7.
Yeah, so I would write this. I would write -5 and 7. And this represents what? X. So what is my inequality? -5 less than or equal to x less than or equal to 7. That's my inequality. Do we know how to write it in set notation? Yes, solution set of x such that -5 less than or equal to x less than or equal to 7. And do we know how to write an interval notation? Yes, -5 is included and 7 is included. So we write interval notation, bracket, -5, comma, 7, bracket. Copy that. And then right now we're going to find the range. For those of you that are ahead of me, go ahead and after you're writing that, find me the range and focusing now on the y. And if you don't see it, use your highlighter so you can focus your graph on the y. All right, and that's pretty much what the home play is going to be about today, guys. Just finding out the domain and range of functions and writing the different notations. So here we go. I'm going to get this out of the way. Now I'm going to focus on the range. Here we go. Where does it start from the bottom to the top? From the bottom to the top, it looks like at -2 and it ends at 4. If you don't see it, here it goes. This function starts at -2 of y and it ends at +4 of y. That means my dividing points are -2 and 4. What variable do I use for the range? Y. And it's less than or equal to because the points are included. Do we know how to write that in set notation? Yes. In interval notation? Yes. All right. That's going to be the home plate, guys, pretty much. Show me what figure outcome you are with domain and range up to right now. 5, 5, 5, 5, 4, 5, 4. Yeah, we got this. All it is that you need to focus yourself in regards to when you're getting to the domain and range. That's where you need to have your highlighters ready, okay? I'll stop right there. Tutoring after lunch. See if you can make it. And if you don't, then have fun. I'll see you guys till next time. Later, guys. Have a good weekend. Peace.